Okay, folks, we're going to take a look at the lab answers that I selected from Chapter 3, Problems 5A, B, C, 12, 14, 22A, and B. 5A, B, and C are problems that we're looking at for the weighted mean. I've written the formula over here to remind us. So, again, what I recommend, like I mentioned in the lecture videos, is to start with sort of predicting what answer makes sense and then do your calculation so you can see if everything more or less lines up. So question 5 says we have one sample with a mean of 6 points and a second sample with a mean of 12 points. And so we're going to combine them into a single set of scores. So A says, what would our weighted mean be? What would the mean be for the combined sets if both samples have 4 scores in them? Well, remember, if both groups weigh the same, meaning, again, they both have an equal number of scores, 4 scores and 4 scores, the weighted mean is going to be where? It's going to be exactly halfway between 6 and 12, exactly halfway between the values for each group. So remember, there's a little shortcut I mentioned we can take. If the groups are the same size, all we have to do is take the mean for the first group and the mean for the second group and average them together. So 6 plus 12 is 18. 18 divided by 2 is 9. So the weighted mean would be 9. But again, you don't have to take the shortcut. Some students don't like to do that. So let's take a look at the formula. Well, we know for the formula we have to get the summation of the raw scores, which isn't given. We know how to figure that out. We know that if we multiply these two values together, we'll get it. So our multiplying our 6 times 4 here and multiplying, our 12 times 4 over here. So we've got 24 on this side, 12, 24, 48 on this side. And now we just plug them into the equation that the weighted mean is 24 plus 48 divided by 4 plus 4. And 9 is still our answer, whichever way we get about it, exactly in this halfway point here. Okay, so question B changes the group sizes. So for B, the first sample has an N of 3. Oops. So we're taking a score out there. And let's see, and the second sample has an N of 6. So we're boosting that one up. So we've got 3 scores in this set, 6 scores in this set. So again, we want to start by saying, well, do these groups weigh the same? No, they have unequal sizes. Well, which group weighs more? The larger group weighs more. So we know that the weighted mean, this combined mean, should be closer to the value for the bigger group. So it'll be somewhere between 6 and 12 points, but it'll have to be closer to 12 than it is to 6 because it's getting pulled or pushed, I guess, from this perspective, shoved over towards the larger group. So now we have to know. So again, we got to get our summation of raw scores. 6 times 3 is 18. 12 times 6 is 72. So 18 plus 72 over 3 plus 6. So when we do the math there, the answer that you should have gotten is 10. And again, it matches our prediction. It's somewhere between 6 and 12, but it's closer to 12 than it was to 6 because it got pulled over by the larger size group. And then lastly, they simply reverse these values. So now there are 6 scores on this side and only 3 scores on that side. So are the groups equal in size? No, they do not weigh the same. Which group weighs more? The first group does now. So where should the weighted mean be? Somewhere between 6 and 12 points, but it's going to be closer to 6 because now it's getting shoved over to the left. Again, the larger size group. So once again, we need to go ahead and do our math. 6 times 6 is 36. Our 12 times 3 also gives us 36. So 36 plus 36 divided by 6 plus 3. And we find now that our weighted mean is 8. And sure enough, that matches once again our prediction. 8 is closer to 6 than it is to 12. So our answers were 9, 10, and 8 for parts A, B, and C. Next up, question 12. Very much like examples I did in the lecture videos. So question 12 says, a sample of 5 scores has a mean of 12. Where'd I go? I lost my place. 5 scores has a mean of 12. If one new score with a value of 18 is added, what is the mean? So we're going to add a score of 18. So we know that we're going to, as we did it in class, we know we're going to need to know what the summation of raw scores for the original data was. So we have to multiply our 5 times our 12. And I don't have that written down, so let me see. 5 times 12, 60. All right, now we're going to add a new score. So what happens? The number of scores was 5. The new number of scores is now 6. When we took all these 5 scores and added them together, they totaled up to 60 points. But with this new score, we're adding 18 more points. So the new summation of raw scores, 60 plus our 18 is 78. So now we know the new summation of raw scores and we know the new number of raw scores. All we have to do is calculate the new mean. So the new mean is the summation of raw scores, 78, divided by the number of raw scores, 6. So 78 divided by 6 gives us 13. Now we should have started with a prediction, really. I jumped right over that, violated my own policy. So we should have started by asking what should happen to the mean. Should it go up or down? We could see that it went up, but we added in a score that was higher than mean. Again, think about it if these were your test scores. You've taken 5 tests and averaged 12 points on them, and you take a new test and you got 18 on that one, you would expect your grade to go up. The mean would go up, and it did from 12 to 13. Question number 14 is another one of this style of question, I suppose. Question number 14 says a sample of 6 scores has a mean of 14. 6 scores has a mean of 14. After one new score is added, the new sample has a mean of 12. So we're getting it a little bit different this way. They added a score, and that resulted in a new mean of 12, it says. And the question asks, well, what was the value of that score? So again, let's think about it in sort of personal application terms. You've taken six exams and you scored an average of 14 points on them. You took another exam and your mean changed to 12. It was 14 and now it's down to 12. So we know you didn't do very good. So we're expecting that this new score is a low score. Well, we approach this the same way we do the other ones. We still need to know what the new score is in here. So what do we know? We know that the new mean is 12. We added a score, so we know the new number of scores would have to go up to 7. We can figure that part out. Now, what else do we need to know? We need to know what the old summation of raw scores was. Well, if there were 6 scores with a mean of 14, again, we just multiply those together. So that told us that before it added up to being 60 points, all of our test scores, if we will. And now we can do the same thing here. What is the new summation of raw scores? Well, we now have 7 scores with a mean of 12. We do the same thing. We just multiply them together. And so we can see that the new summation of raw scores is, I think I wrote the wrong thing. Oh, is 212, 84. Oh, I'm sorry. I wrote an answer for the previous problem up here. I apologize for that confusion. Obviously, 6 times 14 is not going to be 60. 6 times 10, but we got more to do than that. The real answer, of course, was 84. I apologize for that. 84. So again, 7 times 12, what do we get? Also 84. So our old subtotal, if you will, was 84 points. We took a new quiz and we still only have 84 points. So how many more points did we add to the pot? None. Your new raw score is 0. Apparently you didn't take that new test, if you will. So we do that by, again, just comparing what was the old summation of scores, what's the new summation of scores, what's the difference between them. And the reason why it's tricky for students is because they don't expect a 0 here. But let's say, for example, the old summation of raw scores was 84 and the new summation of raw scores was 94. Well, we added 10 more points. That would tell us that the new raw score was 10, right? But in this case, there's no difference. So the score had to have no value. So we get a 0 there. And then lastly, question number 22, parts A and B. We've got a frequency distribution table given to us there. And it's asking us to find some calculation values out of it. So the first thing it wants us to do is to find the mean, the median, and the mode. Well, let's start with the mode, because that's the simplest one. If you just look down the frequency table, look for the highest frequency value you have, and again, you've got the table in front of you. I'm not going to draw it on the board here. It's a 5. 5 is the highest frequency. What score is that associated with? A 4. Oh, well, then we know the mode was a 4. That was an easy one. To get the median, some students deconstruct the table and put out all the raw scores in a long line again and then look for the middle of it. Some are able to reason out where the middle of it would be based on frequencies. Probably breaking it all down into a long line is the safest approach if you're careful, but kind of doesn't matter which approach you take, of course, as long as you get the right answer. And the median you should get is 3.50, 3.5. So that just leaves the mean. And for the mean, we want the summation of raw scores. We know how to do that. Multiply across, add down, and then get the number of raw scores. We know how to do that. Just add up the frequency column. So what we get for the mean is when we get the summation of raw scores, that's 42 points. When we add up the frequencies, the number of raw scores is 14 points. Therefore, the mean for this data is a 3. So the mode is 4, the median is 3.5, the mean is 3. And then B says, based on the values for central tendency, what is the most likely shape for this distribution? So is this normal? Is it positively skewed? Is it negatively skewed? Well, remember, if it's normal, all these scores will be pretty close to each other, and they're a little bit spread out based on this data. So probably not normal. And again, I like to start with the mode. So we think about our number line here. So the highest value, 4. So we know that's the mode there. Which measure of central tendency is the most impacted by extreme scores and outliers? Which one reacts the most? We know it's the mean, and the mean was 3. Right, just a number line here, so we know that's the mean. So we know that this has to go out that way, and we can see that we are negatively skewed. We have a negatively skewed distribution here. Okay, gang, that is the lab items for question 3. Once again, make sure you're practicing, so that when it comes time to do this under the restraints of quizzes and exams, it can just flow right out of you, and you feel comfortable and rehearsed, if you will, in terms of knowing what you're doing. As always, continue to reach out to me with questions you've got. Otherwise, have a great day, and we'll see you on the other side of exam 1 for chapter 4.